you've seen me talk before, you know where your expectations are. I don't have anything to worry about. I did want to quickly though show one thing, because it's going to come back up in the talk real quick. But if I do this and I type the word, the characters WASM here, there's a lot. There's a lot in here. Okay, so I did work on this for a little bit. This project, Express, and I'm going to do my presentation from it. I'm not a very good JavaScript engineer, but somehow I just keep having to do it professionally. OK, so I'm going to click that. I'm going to undo that again because I did that wrong. I'm going to do that. There we go. It's very distant. And I think there, oh, here we go. I put Mendy on here first. That was before he ditched me. No, he's over there. It's all right. So yeah, my name is Colin Murphy. It's a slow intro, a slow open here. My name is Colin Murphy. I work at Adobe. I'm a member of W3C WASI subgroup. I'm a, what do they call it, co-champion for WASI clocks, and somewhat of a maintainer of wasmCloud. I'm going to explain what this is, what Trustmark is, how we use it today. And I'm going to discuss the challenges of AI inference with video files especially, but also images. Then I'm going to hand it over to Mendy. He's got a little bit of a cold, so he's going to mute his mic. Sorry, I'll hand it to Mendy. He's going to talk about how the work he did on implementing WebGPU for WASI. And then we'll do a little demo. In fact, we're actually going to start with the demo real soon because it takes a while. Early days of video watermarking and also WebGPU. So what is content authenticity? What is the Content Authenticity Initiative? So I work on the CAI team at Adobe, but it's actually it's bigger than Adobe. It's an industry standard for provenance metadata to help curb disinformation, increase trust, and transparency online. So I only focus on changing all of compute, server-side compute, and fighting AI-generated images online. So I try to really focus on very small, solvable problems. But membership includes camera manufacturers, as well as editing software, social media companies, and just general media companies. C2PA, it's the standards of content credentials, and COG is Creator Assertions Working Group, which is around you're an artist, you've created something, and you can prove it, essentially, no matter how many people copy and repost what you've created. I'm going to kick off the demo real quick. I'm just going to kick it off. I'll show it at the end, but I have to kick it off now, so because it takes a while. OK. So I'm kicking it off, and we'll come back to it in a second. Yeah, so moving on. I stole a bunch of slides from one of my teammates. But this is the problem we're trying to solve. It's very difficult. It's only getting harder to determine whether an image is AI generated and video isn't that far behind. And so we have kind of these three pillars of what we call durable credentials. So the first is a manifest that's embedded into the asset, into the image or the video, in the metadata, and it talks about what's been done to that image, and there we have assertions and ingredients and things, and then we sign it with an Adobe credential if you're using an Adobe product, right? If you're using a Pixel phone, it's a Google credential, if whatever, right? The camera manufacturer. Or the AI generated, so for Firefly, right? Adobe Firefly or the other services. So it gets signed by them. And so as long as you trust that certificate, you can trust the manifest, right? Because you can say it hasn't been tampered with because you trust the certificate. So that's great. And that's where we started. But But the problem is that that metadata gets stripped off just as normal, the normal operation, normal usage, right? So a lot of providers don't respect metadata. They just strip it out. So if I was to give you an image and put it on Slack, you download it, all that C2PA metadata is stripped out. So that's not great, right? But that's why we have these two other legs. We have invisible watermarking, which I'm going to demo here, which the demo is running, and fingerprinting. So fingerprinting, we just kind of take a hash of the pixels in kind of region, where we can kind of determine, even if you take a picture of a picture, or a picture of a TV that has an image on it, we can, if you then took that photo and took it to our content authenticity website, we'd be able to pull out that dense fingerprint and get, not only get back the original image, but also get back the manifest of how that image has been altered. And then the other one here, getting to the point, is digital watermarking. So it's invisible. That's the idea. You're not supposed to know there's a watermark there, because people, if you were to use Photoshop and you chose to watermark it, you wouldn't really want to see a watermark on what you've made, right? That's typically not the point of using Photoshop, is to see a watermark. This video watermarking demo is you are going to see the watermark. So I made it strong, and also we're still early days. But yeah, so it's invisible. And then what we get is when we take all three of these pillars, we have what we call durable credentials. So that's the point. So we can, even if you've just uploaded and shared it on through some sort of file sharing Dropbox or something, and the metadata has been stripped, you're still fine. Even if somebody actually intentionally tries to alter the digital watermark by passing it through another algorithm, you will still be able to have the dense fingerprint. And then once we're able to recover that, we have the manifest once again. So we have these hard binding assertions, so that we can then show exactly what happened and directly link to the dense fingerprint and the watermarked encoded string. Right. OK. So as I said before, Trustmark it's an open source model. You can download it. It's Onyx. The models are fairly small. And we've got that video one in progress. And so just going to go over how it works today. One, if anyone has used, so for instance, what I'm sharing on right now is Adobe Express, but Photoshop, Lightroom in the browser versions. It's going to be, we are hitting the upper limit of memory usage on a lot of devices, especially mobile devices. And we're not going to just add more stuff, especially Onyx models, into your web page and get, have it get killed by the phone usually, or if you were to change tabs in the browser, right? That's going to be to a really lousy experience. We do currently have Wasm Onyx. We have a Wasm inference, and it's only through a browser extension though. So you can, in your browser, if you download the extension, you can decode. So this is decoding. So it's already been applied, and you're decoding the watermark out. But then the manifest repository, the fingerprinting and the watermark and the lookups happen server side, and then it displays it back. So that's the decoding workflow. And then the encoding workflow is actually you just put the image. You just kind of upload the image. There really isn't any point in doing anything on the device or on sort of an edge compute in this situation, because we really need the whole image anyway in order to process it. And images are small, right? So it's not that big of a deal. But then when we get to video, this is where the edge compute work case really comes in. we currently are watermarking every frame as we kind of work on this. And video files, easily hit 100 gigabytes. It's not that hard to have very, very large files. We don't necessarily want all of that going into the data center, getting processed, and then coming all the way out. Right? That could get pretty expensive. And it just kind of, the math just doesn't really work, and it's a really good use case for edge compute. So Frank, I'm sorry. To be frank, and I think some of this got a little stolen in our conversation before. In the minds of a corporate strategy, right? Web services is a solved problem. As we saw in the recent AWS outage, major technology companies don't even operate outside of US East 1 AWS, right? They basically stop paying attention to emerging web services around Java 8, right? And for the most part. And a lot of the stuff you see here at KubeCon, it's going to be about monitoring and deployment tooling, right? Nobody's really trying to reinvent how web services work. In my opinion, the success of WASI and server-side Wasm in general is really tied to edge compute. And now with things moving so quickly, as they've been for the last couple of years in the AI space, as of at this moment, November 10th, 2025, AI inference at the edge seems like a really good opportunity for complex edge compute to really move the needle on how people do services. And in this particular case, these are the two reasons that you would use edge compute, right? You want to save money, hopefully enough money to do something new, and you want to keep that browser payload small so that your app doesn't crash. So seemingly a good use case. So I'm just going to get through now with the technical challenges of how we did stuff. Mendy's going to cover WebGPU, but I just want to talk about OpenCV. So I actually looked this up before, so I didn't know this, but it's short for Open Source Computer Vision Library. And it's widely used as an open source software library for computer vision, image processing, machine learning tasks. And all of our Onyx models we created were designed with it. So it was very easy to go from Python, that these models were, we have little tools to run these models with Python. It's pretty easy to go to C++, even for someone who doesn't know C++ like me. But it's really, really hard to go to Wasm, to go to WASI specifically. And that's because you can't just compile OpenCV to WASI yet, Luke, but with all the things that Luke presented earlier, we will be able to, right? But I didn't even try to get it working because it's a huge library. I would have spent all my time just trying to compile it. Just in the color space, it was tricky because OpenCV expected RGB. And so for the image, when I got the Trustmark one working, I used STB images for pre and post processing. That was actually pretty easy. The only hard part was the RBG to BGR conversion. For video, it was actually very, very challenging. OpenH264 expects threading. It expects semaphores. I kind of had to stub that out. It was super tricky. I had to actually stub out some of those semaphores. Maybe actually, if I had used some of the things Mendy had used, I wouldn't have had to do that. But it expects threading. FFmpeg for WASI does actually exist, but it would have taken an hour to build it, and I had to do this over the weekend. So didn't have time for that. So this is kind of just what I had to do, what I had to get working outside of the actual WebGPU Onyx runtime. Let's just play around with all this nonsense. The actual demo, the Onyx model isn't yet ready for batch processing, where you can give it a lot of frames at one time, and it'll just kind of crunch them all at the same time. Once that's working, and once we've done some other optimization, I wouldn't have had to have started it at the beginning of the demo. But yeah, so this was a challenge. So now I'm going to hand it over to Mendy, and he is going to talk about what he did to get WebGPU working.
So, work? Yeah, okay. So in order to get all this watermarking working, we needed to get an Onyx runtime to work. And the biggest one is actually called Onyx runtime. And we're running into challenges trying to port it over to WASI. So first of all, it relies on pthreads. WASI doesn't support threads. It tries to get the process ID. WASI can't access the process ID. And it uses exceptions. And WASI SDK doesn't support exceptions yet. So how do we deal with all these kinds of problems? And there were others. I just picked out a few for examples. So for all of these problems, you can actually find workarounds. So for the first one, whoop.
Yeah, we knew that was coming. There we go.
So for WASI threads, actually, turns out a lot of applications that use pthread.h don't actually need it for threads. They need it for things like mutexes and other threading primitives. So you can emulate all that. And there's a flag in WASI SDK to do that. And for process ID, same thing. You can just emulate it. You can just return a fake process ID. Or, as always, this is the implementation of get process ID, which is just 42, the answer to everything. For try-catch, for exceptions, so Onyx Runtime thankfully has a mode where it can build without exceptions. And this is what we're doing for now. It's a minimal build. And fairly soon, WASI SDK should have actual exception handling. So that would mean we can bring like full Onyx Runtime to WASI, which is cool. Some other things we ran into is a lot of applications assume that if it's Wasm, Emscripten is available. So usually this wasn't too hard to like find a replacement, but it's something to look out for. Now, until now we only spoke about like getting it to work on the CPU, but actually getting it to work on the GPU to actually get like speed-ups and performance, that is like the key. So Onyx Runtime already is built on top. It has multiple backends. One of them is built on top of WebGPU.h. WebGPU.h is a standard header file, and you can build whatever application you want on top of it, and it can be backed by a number of WebGPU implementations. There's Donfun from Chromium, there's WGPU from Firefox, and we're working on a WASI implementation for this. So if your application already targets WebGPU.h, you should be able to just retarget it to WASI. Now, for the future of this Onyx Runtime WASI port, we got to do a couple of things. Number one, we got to clean up the code, and we want to upstream all the changes to make this like official part of the main repo. We're going to explore semantic API to make it component native, to make it easy to do inferencing inside components. And once WASI SDK supports exceptions, we want to bring full WASI, full Onyx runtime, even with the disabled features, the things that are disabled right now. And you can now actually try this out in Wasm, CNCF's wasmCloud, because as of yesterday, CNCF wasmCloud supports WebGPU. And if you run this code, you should be able to actually run. This will install the latest wasmCloud and run with WebGPU support in it.
Oh, yeah. So keep it. So, yeah. So the demo. It's going to be super, super overwhelming when I show you. So this is what I encoded. It's a second long. It's from it's the Adobe Firefly, like, welcome to generate video. And here, if I open it, so I'll, OK, do the plus. So yeah, it completed. It takes a while. But if I open it, so yeah, there we go. Okay, so there, yeah.
Colin?
Yes.
Can you bounce up the font at all?
Yeah, I know, I'm sorry. I knew it's always.
Old, Colin.
I'm old too now. This Wasm's made me old. Yeah. So, yeah, all right. Oh, it's opens on the wrong. So here, this is, as you know, this is to prove it. I'm going to say this is, I proved that it was watermarking was work, because you can see all those pixels, all those dots. All right, so yes, so it's been watermarked. All right. But yeah, so it worked. It just takes a while, but we're going to, this is pre-release. And it's also proprietary, so I didn't want to show you the model names yet. Not there yet. But it will probably be open source. We open source the image one. OK. That's it. That is the talk. Are there questions? Are there questions?
What is the edge compute that you would be running?
Surely there are questions.
No, we had one. No one else could hear him, but I was going to answer it.
Did you have one? OK. One moment.
Yes.
So when you say edge compute, what are we talking about?
Yeah, so I made a little, a little logical jump there. So if you can run it in Wasm time, you can run it in wasmCloud or Fermion. And wasmCloud, that's my project. This is not meant as a slide as any other project. WasmCloud's made to run on edge compute. All right, that's where I've always seen it. There may be other people who might disagree, but I think that's, if we're going to push the needle, if we're going to move people, if we're going to make people change how they do web services, you're going to need, I'd like it to be on edge compute. And I think if you're going to do that, you're going to need to do a lot of stuff. I've given some talks recently. In the spring, I gave a talk on Spiffy and how identity needed to be handled across all of these edge nodes. Right? There's a lot on NATs. Other stuff we've done, so I'm trying to do my little part here to build something new and better. But yeah, so if you can run it in Wasm time, you can run it on these platforms. And I'm sure, Luke at Fastly, right? Wasm time there as well. Yes.
So just to clarify, so when you say edge, you mean specifically
CDN.
CDN.
Yes, I'm sorry. CDN edge compute.
So the network edge of the public cloud.
But yeah, but it's right. Network edge is public cloud, but Wasm is made to run on many different definitions of edge. But yes, but I'm talking Wasm time. I'm talking CDN edge compute.
OK. And then, so like from my perspective also, there are other edges, like you say, that are functionally speaking smaller or more disconnected environments that may or may not be on in a CDN POP, might be in some distributed center, could be in a building like this, for example, that are on-prem, but I still think of those as, like, from an IoT point of view, the IoT crowd used to call that edge, IoT edge kind of thing, as opposed to CDN edge. Yeah,
and we had a talk just before, right? Those Raspberry Pis can take advantage of WASI WebGPU too, right? So, I mean, the capability of video processing on even really small stuff has gotten a lot better. So this is how you take advantage of that hardware, is things like this.
Anybody else? All right. Congratulations, you ended a little early. We expect people to run long. Thank you very much.
All right.
Mendy and Colin. OK. Bailey, probably time for you to get wired up.